In today's lesson, we'll be learning about the exponent rules with a focus on the product rule. There are actually many exponent rules, but today we'll be learning about the product rule. Before learning about the product rule, let's review what a term is. Remember, a term can be a number, a variable, or a combination of the two. A term contains, not always, but usually, an exponent. The number 2 here would be an exponent. It also usually contains a base, and the base is typically located below the exponent, and it sometimes contains a coefficient. A coefficient is the number that typically comes before the variable. In our first example, two terms are being multiplied. How do we know it's multiplication? Well, this little dot is another way of saying multiply. I want you to think of the product rule in three parts. The first part involves looking at the coefficients of the terms. The coefficient here would be the number 2, and the coefficient here would be the number 5. You want to multiply coefficients. So 2 times 5 is the number 10. The next part of the product rule is to look at the bases. The base here would be the variable of x, and the base here would be, again, the variable of x. The bases stay the same. So that variable of x is going to stay x. The last part of the product rule is to look at the exponents of the terms. The exponent here would be 3, while the exponent here would be 4. You actually want to add these exponents, which means 3 plus 4 is 7. Therefore, when you multiply 2x to the power of 3 by 5x to the power of 4, your answer is 10x to the power of 7. In our second example, we have two terms that are being multiplied. Again, this symbol represents a multiplication sign. The first part of the product rule is to look at the coefficients. The coefficient of this term would be negative 3, and the coefficient of this term would be positive 2. You want to multiply coefficients, which means negative 3 multiplied by positive 2 is going to give you negative 6, because when you have a negative multiplied by a positive, your answer is going to be negative. The next step in the product rule is to look at the bases of the terms. The base here would be the variable of x, and the base here would also be the variable of the x. Bases stay the same, so that variable of x is going to stay x. The last part of the product rule is to look at the exponents of the terms. The exponent here is 2, and the exponent here is 5. You actually want to add the exponents. Therefore, 2 plus 5 is going to give you 7. Therefore, when you multiply negative 3x to the power of 2 by 2x to the power of 5, your answer is going to be negative 6x to the power of 7. In our third example, we have two terms which are being multiplied. Again, this little symbol indicates that it's multiplication. The first step of the product rule is to look at the coefficients of the terms. There doesn't appear to be any coefficient over here, but if there is no coefficient, there is actually a hidden number 1 there. Meanwhile, the coefficient over here is positive 4. We want to multiply coefficients. Therefore, 1 times 4 is going to give you 4. The next step in the product rule is to look at the bases. The base of this term is the variable of x, and the base of this term is the variable of x as well. Bases are going to stay the same, which means that variable of x is going to stay x. And the last step of the product rule is to look at the exponents of the term. The exponent here is 2. There doesn't appear to be any exponent over here. However, if there is no exponent, there's actually a hidden 1 there as well. We actually want to add these exponents. Therefore, 2 plus 1 is going to give you 3. When you multiply 1x to the power of 2 and 4x to the power of 1, your answer is going to be 4x to the power of 3. Just be careful with the hidden 1s here. In our fourth example, we are multiplying two terms. Again, this symbol indicates multiplication. The first step of the product rule is to look at the coefficients. the coefficient here is 3, while the coefficient here is 2. You want to multiply coefficients. Therefore, 3 times 2 is going to give you 6. Afterwards, we want to take a look at the bases. There doesn't appear to be any base over here, and the base here is a variable of x. Bases stay the same. So even though one of these terms is missing a base, you're still going to write the variable of x since they stay the same. The last step of the product rule involves taking a look at the exponents. Well, since we do not have a base for our first term, that means you don't really have an exponent. While over here, the exponent would be the number 2. Therefore, you can just leave that as 2. Therefore, 3 multiplied 2x to the power of 2 gives you 6x to the power of 2. In our fifth example, we are multiplying two terms. Again, this symbol indicates multiplication. The first step of the product rule is to look at the coefficients. The coefficient in this term is 5, and the coefficient in this term is 4. You want to multiply coefficients. Therefore, 5 times 4 is going to give you 20. Next, we want to take a look at the bases of these terms. The base here in this term is x and y. In the second term, the base is x and y again. Bases stay the same. Therefore, you want to leave the variable of x right over here and the variable of y right over there as well. The last step of the product rule is to look at the exponents of the term. The exponent over here would be 2. There is no exponent over here, but that just means that there is an invisible 1. Meanwhile, the exponent over here is 3. And again, there is no exponent over here, but that just means that there is again an exponent of 1, and it is hidden. We want to add these exponents. Therefore, I'm going to take the number 2 and I'm going to add it to the number 1. So 2 plus 1 gives you 3, and that 3 is the exponent for the variable of x. Next, you want to add 3 to 1. So 3 plus 1 gives you 4. So 4 is going to be the exponent for the variable of y. Therefore, when you multiply 5x to the power of 2, y to the power of 3 by 4xy, you're going to get an answer of 20x to the power of 3 and y to the power of 4. You will have to be very careful with your hidden ones here.